How's everybody doing? Good. Awesome. It's a little early in the morning, but we're going to have a lot of fun at the party tonight. I will be the DJ, so I hope you guys can make it. With that said, let's go ahead and get our next speaker up here. Ladies and gentlemen, I present to you Andrew Widdersheim.
Hello? Can anybody hear me? Okay, cool. All right, so the title of my talk pretty much embodies like the worst case scenario for me on any given day. Nagios going down is very bad for me. I'm primarily responsible for the Nagios install for where I work. So anytime it goes down, I have to go see my boss, and I don't like doing that. So this picture kind of embodies, however, whenever this happens, this is kind of how I feel. And I'm hoping that some people can at least sympathize with me on this one. I'm not the only one that has had something go down. Maybe it wasn't Nagios, maybe it was something else that you're responsible for. But it's probably the worst feeling in the world. You get that like pit in your stomach. And Nagios, and things never go down the way you want them to, right? It's always New Year's Eve, you're drunk, you're hungover, and everything that could have gone wrong went wrong, and you're spending the next 8 hours trying to get your server back online with your boss just hovering over you, asking you when it's going to be done. So we want to try and avoid that situation. This talk is really about trying to minimize the chances of that happening. And the way we'll end up doing that is we'll try and create a like an active, passive, highly available failover cluster. And then once we have our cluster online, we still want to be able to update and make changes to our install without affecting anything in production at the time. And then finally, the other big thing that we want to do is make sure everything's running well, right? Like Nagios, needs to run fast, and it needs to be doing its checks in the proper amount of time. So we're going to try and get to all those things all in this one talk, because I'm not sure if you guys have heard, but Nagios is kind of a big deal. We're obviously all here at this conference, but I was able to come to the conference last year, and the people that you talk to, everybody, you get the feeling that Nagios is an integral part of people's businesses now. Like they're setting up Nagios boxes to watch things that are important to them, and when it goes down, they're basically blind to the things that might be happening. So to use my company as an example, I work for a managed hosting company called iNetU. We're based out of Allentown, Pennsylvania, and we basically attract the clientele that want to offload some of the IT stuff that they wouldn't be able to handle themselves. They just want to be able to focus on their business and not have to worry about some of this stuff. So that ranges from things, so we own and operate our own data centers. So we house their equipment properly, and we can replace hardware if it goes down. We have 24/7 support staff that they can call and ask questions to, or that can respond to issues if any arise. And then, of course, we do monitoring, right? Monitoring, as many of us know, isn't really the simplest thing, right? Nagios can be a complicated piece of software, and it's difficult to set up, it's difficult to maintain, and it's difficult to get right, but it's important. We need to know when their stuff is down, our client's stuff is down, the clients want to know when their stuff is down. And when Nagios isn't running, we're basically blind to anything that might be happening. We use Nagios in a very typical way. We watch our servers, we watch our network infrastructure, we watch our data centers. So there's just too much to keep track of without Nagios. So we have to keep it up. So then we start to look at Nagios high availability options. And this is actually just a short list. I really kind of just wanted to highlight the fact that there's more options out there than the one that I'll be talking about. So I highly recommend going out and investigating these options for yourselves to see the pros and cons of each. And the other thing that I want to say is I'm by no means an expert in any of these. Luckily, we're at a Nagios conference where there's plenty of experts that you can find. So for instance, Merlin by Op5, I'm pretty sure the Merlin developer is going to be giving a talk later in the conference about Merlin. So highly recommend checking that out. The second one in the list is the classic method or model. It's kind of just the name that I gave it. But if you go through the Nagios core documentation, there's basically a bit of a blurb on like how to set up a high availability scheme. I think there's a talk going on right now about how that might work with XI. I talked to the guy last night, and basically, it's just a set of scripts to have a passive and active node, and it'll fail over, but you keep it in sync with NSCA. So after the talk, definitely go check his video out. And then the third option is using some kind of virtualized solution. Like the most common example is you put Nagios on a VMware machine and use vMotion. You know, the virtual machine that Nagios is running on, there's a problem with the host, so you use vMotion to move that virtual machine over to another host that isn't having that same problem. So those are, I mean, again, very short list, but the method that I'm going to be mostly talking about today is using Pacemaker and DRBD. And this pairing of software has kind of become a standard with Linux HA, and it's been used in thousands of places to make tons of things highly available. That's the really cool thing about these two pieces of software is it's completely agnostic to what you put on top of it. You know, you could put NFS on there, you could put MySQL on there, you could put Apache on there. You know, so why not put Nagios on there? Just because we're trying to make Nagios highly available doesn't mean we have to start writing 1,000-line shell scripts and neb modules. You know, we can use the software that other people have written to do this very same thing and get it up and running very quickly and know that we have a reliable cluster. The other cool things about these things are these two pieces of software. They're all open source. They're all free. They come with a great community. Like the mailing lists are super active and really good documentation for all these things. So let's talk about what each of these things are. And we'll start with DRBD because to me DRBD is basically it's the workhorse of your cluster. It's the thing that's going to keep your data in sync between one node and the other. And it basically does it with what I call magic, but it's not magic. It's, you know, just straightforward. But the way DRBD works is it actually lives inside the kernel, and it can get there in two places, or in two ways. The first way is you build and install a kernel module, or the second is in the later releases of the Linux kernel, you can the DRBD code is actually within the mainline Linux kernel now. So you just basically activate it. It's much easier if you can get to the latest releases of the Linux kernel and just use it that way, because it makes updating the kernel much easier from then on, then forward on. Yeah. But if we look at the diagram that I blatantly stole from DRBD's website, each of these peach-colored rectangles is basically their own server, right? You can completely separate these and have them run on their own independently of each other. They both have their own set of disks, and they both have their own network card. But the way DRBD works is we'll say that the peach-colored thing on the left is our primary server at the time, and our on my right, your left, yeah. The peach-colored server is the primary at the time, and the other one is our secondary. And as we're doing writes to our disk, as it would normally, DRBD is going to sitting in the perfect place in the kernel to say, hold on, wait a second. Before you write that data, let me go ahead and send that over the network to my other partner here so he can also write that same data. And we're doing that at the block level. So we're basically replicating our block devices over the network. And it's doing that in real time, like very, very quickly with little overhead. Only the overhead of the network and what your disks are is the only thing that's going to slow that down. So really cool. Again, it's free. It's developed by a company called Linbit. They are the main maintainers of DRBD, and kind of cover all the stuff that I've already covered here. You know, runs in the kernel. I mean, the DRBD has a laundry list of features. I definitely recommend checking it out. Like the use cases for DRBD they extend way past this. So you can use DRBD for a ton of things. It's really cool. But there are some considerations when you start to look at setting up a DRBD cluster. And the first thing I have on the list is really that DRBD is only going to be as fast as your slowest node. And what I mean by that is, you know, typically when you're setting up a high availability cluster, you don't want to just buy a super powerful server that you're expecting to always be running on, and then kind of stinge on your other node, because the idea is you always want to be able to run your resources on any node at any given time without any repercussions. The other thing is, the way DRBD works is depending on what protocol choice you use, which I have down a little bit further. Typically, we run in protocol C, which means it's synchronous replication. So when you're writing data, the I/O is only reported as completed from